So I've gotten a couple emails asking about how you tell where to start, and so I'm going to talk about a couple things. First of all is something that ties into question number 2 on homework 6. It says use the rational, actually it should be the rational root theorem, rational zero theorem, I guess same thing. So rational zero theorem to find all possible rational zeros for the polynomial function. So the rational root theorem says that if you, all rational roots of a polynomial have to be the factors of the constant term divided by the factors of the leading coefficient. So in this case, it really narrows things down. So the leading coefficient is 1, which means the only factors is 1. 1 or -1, because you could multiply -1 times -1 and get 1. And then over here you have the factors of 10, so that would be 1, 2, 5, and 10. So if you divide each one of those by 1, your possible answers are 1, 2, 5, 10. Okay, so again, the way that works, there's another example. So what are the possible rational roots? In other words, what are the possible things I could try in synthetic division? Well, the factors of 3 are 3 and 1. The factors of 2 are 2 and 1. So that means my possible, that doesn't mean they are going to be, but my possible rational roots, or rational zeros, same thing, would be 3 over 2, 3 over 1, 1 over 2, and 1 over 1. Of course, these all could be plus or minus. So I went from an infinite number of possibilities down to 8 possibilities. So those are a little bit sloppy because 3 over 1 is same as 3, so I'll just write this as plus or minus 3 halves, plus or minus 3, plus or minus 1/2, and plus or minus 1. So that's my possible rational roots. So if I was trying to find all the roots for this, if I was going to start with synthetic division, I would use one of these. And actually, another thing you can do is, if you have your graphing calculator available, is you can graph this function. And when you graph it, you find out that it looks something like this. Rough, but knowing that rational roots are what make the polynomial equal to 0, that means they also tell us where the x-intercepts are, if they are real roots. So notice this thing, you can see that it's crossing, it looks like a -3, and -3 is one of the possibilities. So those two together tell me I should try -3. So I'll put that in synthetic division, 2, 4, -5, and 3. So bring the 2 down. 2 times -3 is -6. -6 plus 4 is -2. That'd be 6. That'd be 1. -3 times 1 is -3, and sure enough, it worked. Of course, I already knew that because I looked at my graphing calculator and saw that it did. And so you can see that rational root theorem can help us narrow down the possibilities, but also the calculator can help us narrow down the possibilities. Now, if we might as well just finish this out. So we're left with a 2x squared minus 2x plus 1. And if I wanted to find the other roots, because I found one of them, 3, I could set that equal to 0. And let's see, is that factorable? Looks like it might be factorable. That'd be 2x and 2x and 1 and 1. And no, it's not going to be, because they'd have to be not 2x and 2x. What am I doing? 2x and x. They'd have to be the same sign, wouldn't they? And that's not going to work, because that'd be -1x and -2x would be -3x. Yep, so it's not factorable. So I have to throw in the quadratic formula. So we go x is equal to, actually we expect it not to be factorable also because we saw this bump here. and it doesn't cross the x-axis, which means the roots are going to be imaginary. So this would be negative b, which would be negative negative 2, so that should actually be positive 2, plus or minus the square root of b squared, which would be 4, minus 4ac, so it'd be 4 times 2 is 8, times 1 is 8, all over 2a, which would be 4. Okay, so that'd be 2 plus or minus the square root of 4 minus 8, of course, is negative 4, all over 4. And the square root of negative 4, so this is x equals 2 plus or minus the square root of negative 4 would be 2i. And that can reduce a little bit because I can factor 2 out of the top. So that would be x is equal to, actually maybe what I'll do is just split this up into 2 fractions. So that would be 2 over 4, which would be 1/2, plus or minus 2i over 4, which would be 1/2 I. So my roots, there'd be 3 of them. My roots, or my zeros, again, same thing, would be negative 3, comma, 1/2 plus 1/2 I, and 1/2 minus 1/2 I. In another video, I talked about these imaginary numbers and how they come in conjugate pairs. So if you haven't learned about that, that's something you should definitely want to watch that video. So there's your imaginary, or your 3 roots. Negative 3 is a rational root, and then 1/2 plus 1/2 I and 1/2 minus 1/2 I are imaginary roots. This, you can see this as x-intercept on the graph. Those do not show up as x-intercepts.